butane lighter combusts. It is consuming oxygen to produce heat, CO2, and water vapor. This is the chemical formula for butane. You know, butane, it's an archaic name. It's a Greek-based name. That's just to give the organic chemist that it contains 4 carbons, and is a completely saturated molecule. This is the correct formula for butane. We're going to balance this chemical reaction. 2 tips for balancing chemical reactions: an accordion and a ledger. An accordion is a way to write chemical formulas so you do not forget those tiny baby numbers. Those are key. You cannot change those tiny baby numbers. The accordion for butane looks like this: 1, 2, 3, 4. 1, 2, 3. When we count our carbons and hydrogens, we're going to count from this accordion, so that way we're not going to have to forget that those baby numbers are there. The second thing is a ledger. Now, a ledger is for us to count what is on each side of the chemical reaction, keep track of it. We list carbon, hydrogen, and oxygen are the 3 elements that are present. Following the conservation of mass, if we have 4 carbons on one side, we got to have 4 carbons on this side as our product. If we have 10 hydrogens, we got to have 10 hydrogens over here. The accordion and the ledger are 2 things I don't see on students' papers when they're struggling. Let's fill in our ledger. 4, 10, 2, 1, 2, 3. Focus on one atom at a time to balance out. Let's just start at the top of the list and balance out carbon. Now, I have to, Mother Nature, when this chemical reaction goes on, the products are CO2. So if I need 3 more carbons on this side, it is CO2 are going to be produced. I cannot alter this chemical formula. I have to make Xeroxes or photocopies of it. Now, let me update my ledger. My carbons are balanced. My hydrogens haven't changed. And I have 9 oxygens over here. Carbons are squared away, but the hydrogens still need some work. So let's work on the hydrogens. I need 8 more hydrogens over here, and the only tool I have is to make photocopies of this formula here. So I'm going to make photocopies, identical Xeroxes, until I have 10 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me update my ledger. 4 carbons, 10 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 oxygens. So I have carbons balanced, hydrogens balanced, oxygens need to get into play here. Okay? Now, these oxygens, I can only make Xeroxes of them. If you can kind of see where this is headed, it is impossible for me to get 13 oxygens only. There's 12 I have to add, and that gets me to 14. 2, 4, 6, 8, 10, 12, 13, 14. This is an impossible wrong answer. I can't just pick and choose. I have to make Xeroxes. Okay? I need 1 more oxygen on this side. So I can add a CO2, but that's going to give me 2 more. I'm just going to add a hydrogen because that's going to give me one more. At this point in the game, students are often confused, like, what are you doing? This looks like it's going nowhere. This chemical reaction has to balance because of the laws of Mother Nature of conservation of mass. So I am bouncing back and forth, focusing on one atom at a time. Oxygen is balanced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oxygen is balanced. Hydrogen is 2, 4, 6, 8, 10, 12. Okay. I focused on oxygen. It got balanced. Now I'm going to focus on hydrogen. There's only one card to deal, and that is to make a photocopy of this. And I am not digging myself into a deeper hole. I am refining my guesses to match Mother Nature's reality. I have 8 carbons on this side now, 20 hydrogens, and still 14 oxygens. I'm going to balance up my carbons again. I need 4 more carbons, so I'm going to do the photocopies. Eight carbons. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Still have 12 hydrogens. I need to add more hydrogens on this side. So I'm going to add more waters. So I'm going to add 4 more waters. I cannot emphasize enough how helpful these accordions are, and just taking my time and slowly counting. Carbons, I got 8. Hydrogens, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Hydrogens are balanced. Oxygens, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. 26 oxygens. Carbons are checked off. Hydrogens are checked off. Oxygens are now checked off, but note I have to match an even number. So I can make 26 oxygens here on my reactant side. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. By taking my time and bouncing back and forth slowly, I've now balanced out this chemical reaction here. The ledger is the proof that this thing is balanced. 2 butane molecules combine with 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2 butane molecules combine with 13 oxygen molecules to produce 8 CO2s and 10 water molecules. That is Mother Nature's balanced chemical reaction. It's a 2 to 13 ratio of reactants and an 8 to 10 ratio of products. Note that these also cannot be divided down to any smaller whole number ratio. Thank you.